Ladies and gentlemen, here is a summary for lesson number 8 in Unit 1, where we are rotating figures, we're rotating lines. Okay, today's goal is we'll be able to describe how to move one part of a figure to another using a rigid transformation. Okay, and our first example that we did is we were looking at this quadrilateral, or we're looking at this triangle. This is an isosceles triangle. This side right here measures the same as this side right here. And then we did these 3 rotations. We did 90 degrees clockwise around B, 180 degrees clockwise around B, and then 270 degrees clockwise around B. All right. And now here's the figure that came out when we did those rotations. Notice here how it is a square because all these sides, all 4 of these on the outside, are the same measurement. They measure the same because this is a rigid transformation. When you do rotations, it does not change the figure. So we constructed this figure by doing rotations. All these lines here in the middle, all of these lines right here in the middle are the same. These because it is isosceles, and rotations keep the sides the same. Nothing changes there. All right, then the second part we did here, we did rotating a line segment. Okay, we did 3 rotations here on this line segment. We have this line segment here, AB, and then center. Oh, here's another point point C. And then we did these 3 rotations. Notice that they are all the same, 180, 180, 180. The difference is the center. The first one will be center B, the second one will be center C, and the third one will be around the midpoint. So we'll demonstrate each one. Okay, there's the first one, 180 degrees around center B. So there it is right there. Notice how the line is long. The line segment is extended. It is twice as long, and it is still making a line, a continuous line segment. It goes longer. B does not move because B is the center. The next one, 180 degrees around C. Here is center C. Notice how the line came around this way and around to right here. Notice how the 2 lines are, the line segments are parallel. Okay, you see that there? They are going in a same direction. Notice how the order also changes because it is a rotation. And then the third one is going to be 180 degrees around the midpoint of the original segment. What is the midpoint? It is the point that is exactly in the middle, right in between. So that's this point right here. D is right exactly in the middle between A and B. And now we're going to rotate 180 degrees. Okay, you see it there. What happened? They changed position. It doesn't look like we did a rotation. We actually did. A is over here now, and B is over here. So look, when I go back here, you see how they're in a different. A is on the left side, and then B is on the right. When you do that mid rotation around the midpoint, they all line up, but they are just now in different positions. So here are the 3 important ideas of what happens. Rotating a segment 180 degrees around a point that is not on the original segment produces a parallel line to the original. So that was the second one that we did. The lines were parallel. Okay, when the center is the midpoint, the rotated segment is the same as the original, except the vertices are switched. That was the third one. A and B switched positions. And then here, this one, when the center of rotation is at an endpoint, the segment together with its image form a segment twice as long. And that was the first one that we saw. Okay, so there are today's goals. We described how to do one movement to another using a rigid transformation, noticing that the lines were parallel and that they overlapped each other when we did those rotations. All right. Thank you very much.